Hello again, and welcome back to the Mac OS platform layer for Handmade Hero. My name is Ted Bendixson. I will be taking you through this glorious journey, and it's a good morning. I feel like I've got some coffee, and just kind of ready to hammer this out. And I'm actually just sort of feeling like a little bit guilty about. Kind of not explaining strings all that well, and then also kind of there's just a few things I kind of don't like. Yesterday I kind of don't like about what I did, but one is like using this sprintf while we have this like string concatenation function. So I don't know, like that just seemed like, why are we doing two different ways of concatenating strings? That doesn't make a lot of sense. So I'm just gonna kind of put like a to-do here, like put all of this into our own string functions or whatever. So that's fine. Yeah, overall, I don't feel like my explanation was that great yesterday. So it's kind of like redemption mode. I left you sort of in the middle of things, which I really don't like to do, but that's kind of how it goes sometimes. And I also just think that, when I do things like sort of in the evenings, I'm probably not as fresh as I could be. But all of that said, we are going to soldier forward and make some stuff. So if you remember where we left off, we were right in the middle of this debug platform read entire file. So the goal here is to read an entire bitmap file, in this case the test bitmap that comes with the game, and we now actually have, because remember on the Mac, kind of an annoying thing is everything runs inside of a sandbox. So your application runs inside of its own little sandbox, and you don't really get much access to the file system outside. Usually when you try and touch the file system outside, good old operating system comes in and smacks you down, gives you a crash, and we don't like that. So we have actually gone through the effort of building in the previous episode, we went through the effort of building the directory, a string that really just represents like where we're loading this thing from in the file system, and that is inside of the application sandbox, inside of the bundle. So that's really what's going on here. Now that we have that location, that sort of file URL or file path, what we can do, we can actually start like reading some data. So first thing that we want to do is we want to open the file. So we would use and we're not really using, just for a little bit of clarity, we're not going to use a lot of the different file APIs you can use. With Cocoa, you can get like NS File Manager and sort of this like object-oriented wrapper around all of these file access functions. And there's a few reasons we're not going to do that. One reason we're not going to do that is, well, largely because I want to stay a little bit lower level and kind of try and avoid doing too much object-oriented stuff if we can. That API isn't bad. I actually, just the NS File Manager, it's okay. Like, it's all right because at least it's not like allocating memory for us. So we don't really have to like do any memory management with it. So if you wanted to do that, like, there's no reason why you couldn't. So of all the different like sort of Cocoa / object-oriented style APIs that we could be using, it's actually one of the better ones, I think, just because it's not, it's not doing all these like allocations for us and all this like other stuff under the hood, or we don't have to like allocate a struct and then pass it, or like all this other stuff. But actually, the bigger reason why I think why we want to go with these like lower level file APIs has to do with a little bit later, because a little bit later on, we're going to do this live loop playback editing with a memory mapped file, and really the only way to do that kind of a thing is using these sort of like lower level file access APIs. So it's just that kind of feature, at least to my knowledge, I think I tried using NS File Manager for it. Just really isn't like there's not enough hooks. There's not enough is like left open for you to access in order to be able to use that. So that's kind of the reason that we're not going that route. So totally fine route if you want to go down that path, if you want to do it. But I'm just kind of saying, that's why we're not using those. So what we're going to use instead is this fopen. So I actually have to look. This is another BSD. So fopen on BSD, right? So if I look this up, and a lot of these are the same, like from on the Mac, and so fopen. So char star restrict path. Wait, what? Okay. Path. Yeah. Oh, and then the mode. Okay. I don't know what a char star restrict is. That seems like a. Anyway, it shouldn't matter. The idea is we have the path here that we're passing as char star, and then we've got the mode, which we're passing as another char star. And in this case, we want the path is going to be so. Oh, and by the way, this returns a FileHandle, which is like a file star. So yeah, so this thing right here, you can do a few things with these file handles. So that's what we get with that. So we're going to say file star. I just call it FileHandle. Nothing super fancy there. Equals fopen, and then we're going to say we want the bundle file name, right? Oops, not that. Bundle file name, and then not that either. And then I think what we want, so this this next thing I say R plus because that's actually those are the access privileges I want to say. So the mode, yeah. So let's kind of go down here and look at the mode string can also include the letter B after either the plus. Okay. The argument mode points to a string beginning with one of the following letters. R is R open for reading. Okay, string is positioned at the end of the fail if the file does not exist. Okay, so we want to be able to read, right? And then an additional plus following R, W, or A opens the file for both reading and writing. Okay, I actually think that we want this. At least so far as I recall, when I was doing bitmap loading earlier, if I didn't put the plus in, like the system would crash. So basically, like with these access kind of specifiers, and again, like Mac OS is pretty darn like strict about things. So you'll just flat out crash if you don't have the right access privileges. So that's kind of the deal with this plus here. So yeah, if you want to crash, you cannot include the plus. But I decided I wanted to include the plus because I don't want to crash when I read files. So mode string can also include letter B after either the plus or okay. Yeah, so we want R plus. All right. So we got this file handle, and we're gonna now we want to do is it's possible that we were not able to open that file for reading, and if that happens, then file handle is null, right? So if file handle not equal to null, right? Then we're gonna do some stuff, right? A lot of things we want to do, and then otherwise, if we just don't have a file, we're not gonna do any. We're not gonna like crash or anything. All we're gonna do is just log the thing. So log this, and the reason we're not doing anything super robust right now is because this is a prototyping layer. It is for exploring a game idea or concept. It is not about doing the full official engine or anything like that and like handling everything. Like it's okay to say, all right, later on we'll log this. All right. So next thing we want to do is we want to figure out. Well, we want to figure out how big is this thing, right? And I think the reason we want to figure out how big this thing is because of the way this API works. Is we need to tell it like how many bytes to read So to do that, we need to figure out how many bytes the whole file is. And remember, these kind of like file star APIs, they're sort of like, as Casey points out in Handmade here, they're like a they're like a streaming API. And so what we want to do, we don't want to like stream a few bytes through the system and then like stop and then stream a few more. Like what we want to do is what this function says we're going to do, which is like read the entire file. So to read the entire file, we want to figure out, okay, how big is the whole file. So there's this function called Fseek, and I believe you got to remember. Okay, so Fseek, let's look that up actually. So Fseek is here. I've got it open already. Okay, and that so that returns an integer. We're going to say like a U64. So return a UN64. We'll just call it file size, right? And that is equal to, so we're going to do an fseek on the FileHandle. And then, so there's actually some special, let's see the parameters. So the offset, okay, so the offset is like how far from wherever you're, like seek a certain distance, but then like it wants to know how far from where you started. And then they give this like really funny parameter in here that's like this, like whence, which is like, okay, like that's cool. Which is definitely like, means I'm going to be looking that up. So, all right, it tells the file position indicator for the stream pointed by the stream. New position measured in bytes is obtained by adding offset in bytes. Okay, so we want to know that to the position specified by whence. If whence is set to seek set, seek cur, or seek end, the offset is relative to the start of the file, the current position indicator, or the end of the file, respectively. So if we just did like no offset, right? So pass 0 into as the middle parameter, and then do like seek end, then we will get to the end of the file, and yeah, it sets the file position, the new position measured in bytes, right? So that new position measured in bytes is what gets returned from the function, and that's what's going to tell us our file size. Because if we seeked all the way to the end, then we're going to know kind of like how many bytes are in the file to the end. So let's do that. So FileHandle 0, was it seek end, right? Okay. And now, if that file size that is returned is greater than 0, then we've actually got a file that we can read. So I'm just going to do another like if file size kind of thing, right? Because if it's 0, we'll just bail from that. And another kind of like otherwise we'll just we'll make sure that we log it later on when we're doing like an official kind of platform thingy. So we'll log that. So yeah, if we've got a file size, then we want to probably let's see. So we seeked to the end. Oh, wait a second. What is returned? Successful call. Current value of the file position indicator for the stream. Oh yeah, that's right. So we have to fseek the thing. Hang on, I gotta remember what I did that was working. Yeah, so I fseeked. Oh, okay, yeah, gotcha. So we don't actually use the return value. We just use the file size. All right. So we want to do then. So this is just we just fseek the thing and then yeah. Then we use this other thing called an ftell, which I think is just FileHandle. We just pass FileHandle. Let's look at ftell. What's that take? So ftell. These are pretty simple functions, but okay. Rewind. Oh yeah, so long ftl. Okay, so that just takes a and then that just takes a file pointer. Okay, so that's going to tell us file size basically. So that's good. So then we have this now, and then if we have a file size, then we're going to go in here and we're going to first of all, I think we want to like f rewind to the beginning of the file in order to read it. So let's see, f rewind. Okay, let's just say BSD. Okay, no, it's just rewind. Okay, so we just rewind it. Do we say we may need to say beginning? Oh, this is still Fseek. Wait, what? F rewind. Since rewind does not return a value, the rewind function returns no value. All right. Again, cheating. Oh, I think so. If we just rewind, then we'll just get to the beginning of the file. So there is no f rewind. It's just rewind. We pass our file handle. Okay, so now we know that we need something that is like this size, right? So we know that. So we actually are going to do some memory allocation here, just for the debug platform layer, and just for this one file that. So we have this other to do, which is free the file memory, because we're going to want to do that later on. We're going to want to have a function that will free the file memory that we're going to malloc here. So we're going to do contents, or we're going to do result.contents equals malloc file size. So we're just going to malloc a chunk of memory that just represents all of that file that we got. So I think, in this case, that image that we're reading is just that bitmap is like a few megabytes. So we're going to malloc that, and then I think, was it if contents are not null? Yeah, got to be so. If we successfully malloced that thing, then we'll continue to read some data into it, and then otherwise we've got another condition that we may want to log. So I know it's a lot of file streaming stuff. Like there's just a lot of possible places where that can fail. So I want to say let's look at fread, because I think that's what we. So I'm pretty. It seems like a lot of these. Once you kind of get a familiarity with some of these APIs, you kind of figure out what are some of the kind of common things that they want you to do. So I'm guessing that since most of these, like I've passed a file handle as the first parameter, I'm guessing that that's what I want to do here too. But let's look up fread, even though I've totally done all the code and all of that. So fread on FreeBSD. Let's see. So fread restrict. What's the pointer? So maybe I'm wrong. Okay. Fread, if I remember. Storing them at the location given by the pointer. Okay, so I'm wrong. Looks like what we need to do is instead store them in result.contents, right? So that's the first param, and then the size. So number of I think the size is just the number of bytes. Shooting for the number of bytes for it. So that's just going to be our file size. So that's just file size, and then we've got nmemb. nmemb reads nmemb objects, each size bytes long. Okay, so it's just one thing that we're reading, right? So we're just going to read a single thing from this file stream, and yeah, so I think we just say 1 for that, and then we pass the file handle as the final parameter. I'm just going to double check that I got that correct. File size, file handle. Okay. Oh, and then so another thing too is that that returns the number of bytes that were read from the stream. So you have kind of an error checking mechanism that you can use here. So okay, so now we can get the number of bytes read, and so if it turns out that the number of bytes that we read is the same as the number of as the file size, then that's great because we read the whole file as we wanted to, and so that means we've successfully read the file, right? And if not, then that's another kind of error condition where it's like something happened, like maybe no bytes were read, or usually that's going to be like no bytes read, I'm guessing, because I suppose it's possible that I don't know. Maybe I don't know enough about the way that API works, but maybe like something happens in the file system, like while it's reading, or like maybe it's a big file and you like yanked the hard drive out in the middle of while it was reading, and so it like returned from that function, and then this thing that you got back was like not equal to the file size or something. Like I guess that could happen. So in a full shipping game, you would probably want to handle that circumstance, right? You would want to know what to do with that. So, but in this case, we don't really need to. Remember that the result also has like a contents size parameter in it. So all we're going to do is we're going to set the file size as well. All right. So we successfully read our file, our content size, and I want to say that's it. Okay, yeah. Right. So in that other circumstance, we want to do more than just we want to do more than because we allocated some memory, right? So if for some reason we weren't able to fully read everything, so we need to clean this up if it fails, right? So think of it this way, like so we got this far, right? So we know that we've got a file. We rewinded our file handle. We know we've got. We know that we're like about to do this read, and we need to read it into somewhere. We need to read it into some kind of temporary buffer, right? And so this is what that content is. Well, if for some reason, we mallocked this thing, right? So we got ourselves some memory, and then we got down here, and so in this case we've allocated some memory. Well, in the success case, great, we just use it, right, and then we're done. But in a failure case, it's like we've got this memory kind of hanging out, and that's not good, right? So we definitely want to get rid of that. So we need to first of all come up with a function to free the memory. So that kind of gets me into my next sort of thing, is freeing the memory. So we've got this, yeah. So we've also got void. We'll call it debug. I think he calls it debug platform free file memory. So it doesn't return anything. Debug platform free file memory. Okay, so here we go, and that takes just a void star to the memory, which gets freed. So we're going to want to implement that, and I believe that we would want to do that just above. Well, actually, no, wait. I think that we could do it below. We'll see if we get any other errors, but no, because we did a forward declaration in that other file, so we should be able to just. And this is really simple. If memory, right? Free memory. So nothing crazy there, but just something that we want to have taken care of. And then we just pass a pointer to the memory, right? So pointer there, and then we also we want to say that the results, the content size is nothing, right? So for your file memory, ready to go. So let's step through and just build it and see what we get here, and walk through it again. Whoa, okay. Well, definitely made some errors there. Okay, this we had earlier. File. Okay, undefined identifier file. There's probably, I'm guessing there's some kind of like library that uses that. I forget which, maybe it's this DLFCN. Could be. I don't think it's sysstat. You gotta remember. So the thing is, this file stuff, just we don't have that. So let's see if I'm kind of guessing at this point. So there we go. No file. Well, that's not it. Do we have dyld.h? Yeah, we've got that. Mock init and mock time. Do we have those? Yeah, we've got those. Maybe it's the sysstat. No. Well, shoot. Use of undeclared identifier file. Okay. Right, and that's a file star thing. This seems to know what one is. What the heck? We've got a lot of these. All right, I'm just gonna quickly look at. Okay, so this was from my handmade.h. Huh. We're missing some stuff here, so I'm wondering if we're missing like some kind of file IO library. I don't think it would be Quartz Core. That doesn't make a lot of sense to me. So, all right, maybe it's in our build script for the official AppKit IO kit. Do I have IO kit? You may need IO kit. I've got IO kit. What a mystery. AppKit IO kit Quartz Core Audio Toolbox. So this is like, you know, real software development, my friends, is just, okay. So, Mac, file star, library. No, that's not what I want. No, this is not what I want either. FreeBSD. BSD file star. Maybe this will tell us which library it's in. says standard. Oh, standard IO. Duh. Fucking. Oh, but I have that. Then why? If I have that file, then what is wrong here? That's standard IO. fopen. Where is this located? Yeah, it says it's in standard IO. Well, that's weird. All right, so maybe there's something else wrong. Use of undeclared identifier file. Let's go to 109. Doesn't seem to know what a file star is, even though we included that's very strange. Wait a second. This one doesn't include standard IO. What if I don't include standard IO? What does that do? No. Did you mean C file? No, I didn't mean C file. What the heck? I still don't know why. Oh, yeah. What am I doing with quartz core? That just doesn't make any sense to me, why that would be. Is it in DYLB? No, but I have that already. Okay. Gosh, I feel bad now because this is like gonna take, I don't know why this is doing what it's doing. So I made this one yesterday, this file IO one, and that was working. And no. I swear. That includes standard IO. That only includes all of these things. What's the order here? Okay. I had if handmade internal, but I don't know why that would do anything. I don't know why that's able to get a file star, but then the other is not. Or at least it doesn't seem to understand what a file star is. Did I just do something really stupid here? This doesn't make a lot of sense. Why is this not as like an identifier of some kind? What the heck? This doesn't make any sense. I guess we have, if handmade internal. That doesn't, I don't see how that would make it matter. I know that we had that. We only want to do it on internal builds. That doesn't make it so that something isn't seeing, or something isn't like, doesn't know what a file handle is. We've got the file name going up through here, path, file name. We're making the file name, but then everything is fine, but we don't, but it doesn't seem to get what a file star is. Is there something like NS file? Okay, wait, what? C file. Core services. All right. I'm just reading this now because I'm confused about what. Yeah, I mean, okay. This is oh God. All right. I am keeping this off of the cutting, you know, I am including this in the video even though it's frustrating. And the reason that I'm including this in the video is to highlight the imperfection of programming and how people who even have a lot of experience very frequently make really stupid mistakes. And this is an example of that. It's just all that this was. It was not, you know, forgetting to include like the file, you know, or like anything that I thought it was. Like, and obviously, like, there, you know, I should be smart enough to know that if I included the right stuff, that it should work, you know, like trust my instincts a little bit better. Literally, like, just I forgot to uppercase all of these because this is a uppercase. That's just like what it is. It's all uppercase. If you don't do it that way, like, too bad. Watch as this like probably builds now. All right, one one warning and one error. All right, so unidentified memory. Oh yeah, that's right. So memory. Yeah, so what we're doing is we're freeing we're freeing result.contents, right? So that's what we want. All right, one warning generated. Fine, I can live with that. Open up Xcode because we're going to step through this and make sure that we are, in fact, loading that bitmap. Oh my gosh, that's embarrassing. I don't have an owl of shame. I've got maybe this is like my moose of shame. So this is the super chewer. Yeah, I know, super chewer. I know, I'm an idiot. I know. I'm aware. I know. No, I know. I wasn't able to foresee it. Do you know why? Because I make stupid mistakes. Here, you can watch. Yeah, so my moose of shame. So let's see here. We are at, yeah, so we're doing my video tutorials, day 19, and then I've got to open my Xcode projects and point in the right stuff. So we're going to do all that. All right, so edit this. All right. Feeling pretty dumb. All right. So, yeah. All right, so day 19, and then the build. Right, okay. So there we go. And now I ought to be able to step into this read entire file right here where we care to be. So we're going to run that. And then we should just hit that breakpoint immediately. And we do. And so we're just going to step through and see, did we get a file handle? Looks like we did, so that's not null. We're going to seek to the end. Okay. Did we get a file size? Yeah, so this is in bytes, right? So that's, let's bring out our spreadsheet. Just to, what I want to do is I want to make sure that, you know, we've got like the bytes that we loaded in map. So we're just going to copy that right here. 235.9. Not so easy to copy. Geez. 235.9434. Right. So that's just this thing divided by 1024. Right. And then that's this thing divided by, it's like 2 megabytes, something like that, 2 point something megabytes. So all I'm doing is I'm just kind of, cross-checking that. If I open up this package here and I look at my contents and I look in this background, how big is it? Yeah, so 2.4 megabytes. That corresponds roughly to what we've got here. So it looks like the file size is pretty much spot on. So that's good. We can get rid of that. All right, so we're going to rewind, and then we're going to malloc, and then if we have contents, then we're going to read. So we're going to read into this contents, the number of files. All right, and then if we do have bytes read, which it looks like, wait, what? Okay, so there's something wrong here. Bytes read. Oh, all right. So I think I got that wrong as well. So what I think it's supposed to be is, oh no, wait, that's right. Results. Oh wait, so it's 1 then file size. What the heck? So I did file size then 1. Okay, so it's like, oh, maybe it's what I want to do is I want to read like 1 byte at a time, that file size, something like that. Makes sense. Right. Whatever. What I want is that and space, then FileHandle. All right. So we rebuild it, and this time, but actually that was good because it showed how our kind of like error preventing logic like really kind of helped us out, because you'll notice that the bytes read did not equal the file size, and so we dropped into this free the memory and set the content size to 0. So we successfully like cleaned up after ourselves. But let's kind of like run through it again. So we're gonna do that. Okay, great. How many bytes do we read? Bytes read matches file size. Excellent. So we've got the content size now, represents the correct thing. And now we're going to go through all these else's, and we're going to return back into the platform layer. Exactly, where we are. So that's excellent. Very good. Now I think we kind of want to step into possibly writing some stuff. So excellent. So we're able to read. That's very good. Probably also what I want to remember is, okay, great. And then, okay, yeah, so so that's we want to, what else will be able to write a file, right? And we're going to do that. And what that's going to do is, so we're gonna pass that thing, we're going to pass it the file where we want to write it, right? So we'll just have some directory. Again, what I want to do is I want to make sure that like we're writing stuff inside of the bundle. So we're probably going to keep a similar kind of like bundle logic in there. And then just what's the size of the thing, and then the, a pointer to its memory. So you notice that this thing is going to be just pretty much the same. Like what we're going to be passing it is the content size for this read file result, because we're going to get one of these back, and then we're just going to pass a pointer to that memory into this thing, into the read entire file. So we need to make sure that we're actually using these. So we're gonna just kind of copy them, and then we want to just do this once in the game update and render. So down here, right? So we got this, right? And the ordering is almost certainly incorrect. So we got this read file result. We don't want to free the memory until we're done, so we're going to move that down. So we got this, yeah, write entire file. All right, so where are we going to write to? I don't know. So what I'm thinking is that the write entire file for now is just going to go into like the contents directory. It's not going to go into the resources directory or anything like that. So we'll just call this like just write result .bmp or something. I don't know. And then the file size that we're going to pass is just going to be the file read dot content size, right? And then the memory we're going to pass is just the file, file read dot content size, and we're going to pass like the file read dot contents, right? Okay, so now we need to actually go ahead and in the platform layer implement that thing. So I'm going to copy this. We already have the free file memory. Wait a second, did I? Yeah, okay, I left that stub there. I don't want to do that. And then when we're done, we just want to. So first thing too is we probably want to say, okay, well, if file read dot content size is greater than 0 or something, just to we don't want to do anything if we don't want to do any of this stuff if we didn't actually get something out of there, just to kind of be safe, I guess. I don't know. All right, and then we got this thing here, and yeah, so we're going to pass in probably the contents, right? And then that'll just so we're gonna load the bitmap, then we're gonna like write it inside of the bundle app sandbox or whatever we call it, and then we're gonna wash our hands of the memory, so to speak. So that's sort of what we're doing, and the goal is just to test how this thing works. We already have this free memory thing, so that's all good. We want to go and get the all right. I feel bad because this thing is this is becoming less and less like this sort of wholesome entertainment for children. I curse too much when I get frustrated. So oh well, that's real life, So yeah, we're gonna take this file name and so far, just for now, I think we want to do something very similar to what we did here, and the only difference is we will want to we're just going to want to change this to a different local file name. So we're going to just say contents instead, right? And then, yeah, we don't need to see that again. So we've got all this stuff. We may, because this logic has occurred like in more than one place, we may want to do some cleanup and consider kind of compressing it. So consider cleaning this up. But we've basically got this this file name path, and now so this thing returns a true, a bool if it did successfully write. So again, we want to get a file star uppercase. I know, I'm aware, I know, uppercase to get the file handle, and then open. So you want to use the same bundle file name, right? And then we just want to do I believe it's just W. So I want to make sure that that's correct. Reasonably confident. Oh yeah. Yeah, so it's just F open with with a write, okay. And yeah, so yeah, I guess another thing too that I had not done is I just, because remember this is going to returns a Boolean, so we want to just make a result and have that default to false. And then if we successfully read, then great, we'll do that, or successfully wrote. So if we were able to get a file handle out of that, great. Otherwise, log it, move on. And then, yeah, I just want to make sure that I return this result, right? So if I have a file handle, then we're going to start writing some stuff. And then, yeah, so, oops, bool32 equals. That's not right. Oh, wait. No. My ability to move around Vim is slowly improving, but is also just kind of horrifically bad. So let's see. We got our result. That's false. And then I think we just do result is fwrite. So let's look up this fwrite function. I know I've already got the fwrite BSD from the standard library. Fwrite. Okay. So let's see. I'm guessing that's like, oh gosh. Okay, so this is like very similar, right? Because what we're gonna do, this is similar to what we did with fread, except it's just the other way around, right? So the first thing is like the pointer to the memory that we're gonna write. That's just memory, right? Because we pass that in up top. And I'm looking at, okay, and this returns like a size, I don't know, size t, right? So if that returns, yeah, so I guess size t just represents the amount that's, so like we just do like a bytes written. So that would be uint64 bytes written fwrite memory. So, and then we're gonna, so memory is the first one. And I want to say it's the, did we do, okay, yeah. So 1, then the file size, right? Then the file size. And the final thing is we pass the file handle, right? So that's going to tell us the number of bytes that we are written to at that, at that location with the file handle. And what I'm supposing is that if the number of bytes written is equal to the file size, then we successfully wrote, right? And in that case, result equals true, right? And then otherwise, frowny face, moose of shame, we just log it. So that's my guess as to what is going on here. So let's give that a shot and just kind of see what happens. Can we build? 2 warnings. Okay, same warning about, and like I said, we're going to go over some of these warnings and kind of start getting rid of them. So, but I don't want to, spend too much time on cleanup stuff. So we know we can read the file, but can we write it? So let's find out. Let's put a breakpoint in there. We know we're gonna be calling that. Wow, that was fast. So we know, okay, we built our. Now, did we? Because I know that we used. Okay, so we got this. We got a folder name, right? So that's excellent, and that's in our contents directory inside of the application bundle, which we want. And now we have the file handle that's open. Okay, so did we get a file handle out of that? Looks like we did. All right, so now let's figure out, did we write those bytes? It looks like we did, so the number of bytes, and that equals the file size, so return true. Great, and now we're back to our tone. Now what I want to know is, now that I've got this this application bundle, so to speak, did we let's look inside. Let's open up the bundle. It's like a big Christmas present, and there we go. We've got something here that it looks like is trying to be, but I think I think the system's confused about what this is. Like, I think you're usually supposed to like write some headers or something for a bitmap file. What I do know is like this works if it's like a text file or whatever. Like it will certainly, and it's like it is the same size. So I wonder what's going to happen if I try and could not be opened. It may be damaged. Okay, so we don't know how to write bitmaps properly because we just imagine like what we did is we just all we did is we just took the memory for that thing and just like slammed it into a file. So there's obviously like some things that we would want to kind of improve upon. Sure, like later on we'll do that, but for the time being, like we know that we can put some we can put a file in the file system, and really like for the well actually you know what, I think we'll leave this for now because we'll get back to it later. We're certainly going to be using this thoroughly when we go and do like the looped live code editing. So I think it's fine to kind of leave this for now because we're gonna have to use it next time, and we'll kind of make it a little bit more robust. But I'm pretty happy that like what we've got the full kind of cycle of file I/O going on here. So we've got the ability to read a file and then kind of examine its memory contents, and we've got the ability as well to then write the file somewhere within what we would consider to be like the safe app sandbox for this thing. So I'm reasonably happy with that. We probably want to clean this up, cleaning this up slash, as Casey likes to say, compressing it, right? So this is the idea of, we got logic here that looks pretty darn similar, right? And we're calling it in two places. We probably want to remove the duplication later on and just kind of, I think what we'll do is we'll have like a bit of a cleanup day where we go over some of this stuff and like, we'll just clean this up, kind of compress that into a single function. But I sort of feel like, I don't really want to be spending the next 30 minutes or so, kind of shuffling all this stuff around or like trying to find like a good way to do it. So I sort of think that this is a good spot to stop because we've got file I/O. It's more or less working how we want it to work, and we can kind of move on to the next part of the series. So again, sort of annoyed that I made some pretty silly mistakes here, and the Moose of Shame is kind of looking at me like, he's shaking his antlers. But we got there. We got some file I/O, and there's a lot of really cool things that we'll be able to do with it. Next up is, I believe, video sync. So we're going to enforce a display refresh rate. So the idea being, we want this thing to refresh kind of at lockstep. We want to say, because right now if you run this thing, we got like a pretty high frame rate, or like a frame rate that's like very out of control. So like on one frame it'll be like 60 frames a second, the next frame it'll be like 70 or like 80, and there's a lot of good reasons why in a game you want to have a consistent frame rate. So we want to say, okay, 30 frames a second constantly, or 60 frames a second. Big reason why is you don't want to be changing. What's underneath the system while it's like redrawing the screen. So if the system's like redrawing like what's on the screen, right, and then you change what it's reading from, right, you change that buffer, then what's going to happen is the stuff that it just wrote here is going to be different from what it's about to write down here, and it looks like the screen is torn in half. That's why they call it a screen tear, and that's where that term actually comes from. So we avoid kind of weird graphical things like that by enforcing a strict frame rate. So that's kind of what is up next. So yeah. Let's see. If you would like to, you can support this on Patreon. I also recommend you go and support Handmade Hero. Go and buy the thing. You'll get access to all the bitmaps and graphics and the full source code. The source code for the game library is really useful. It will more or less match what we're doing here. But yeah, that's just going to be super important to have access to, because kind of as you're going through the series and kind of like watching Casey program, there's times where he just makes like a lot of changes, and it can get kind of hard to follow. So having access to the source code is pretty important, I think. It'll kind of make your life easy. So yeah, there's also a Git repository with this code on it. It doesn't have the code that is specific to Handmade Hero. It only has the Mac code, the Mac platform layer. And again, that's because you should just go and buy it. And yeah, so follow that. You can use this totally open source, free to use to do your own platform layer. A few people have already forked this already and have started doing some cool things with it. So that really was the goal behind the series from the very beginning, was to give creators a way to make their own game engines on the Mac. And so I feel pretty happy in having contributed to that goal somewhat. So definitely use those, and I will see you next time.